So we'll begin our discussion of trigonometry with what's known as right triangle trigonometry, which is a gentle way to get used to the ideas and the key definitions of trigonometry. So let's put up a right triangle. So here's a right triangle with vertices A, B, and C, and we're calling the angle at B theta. And that will help us name that angle in an easier way. Let's not forget what the Pythagorean theorem says, because that's going to come in to be very important. And we know that a squared plus b squared is equal to c squared. So that's all we need right now to actually define the 6 trigonometric functions based upon the ratios of the sides of a right triangle. So what you have in front of you are the 6 trig functions. This is sine theta, cosine, tan, cosecant, secant, and cotan. So those are the names of the 6 trig functions, and what I'll do right now is fill in what they're equal to. So here we have the 6 trig functions defined. Sine is going to be the quotient of b over c, cosine a over c, tan is b over a. These are all for this angle right here, theta. Cosecant is just 1 over sine, so it's c over b, and similarly secant is 1 over cosine, and cotan is 1 over tan. And those are the ratios of the sides that define the 6 trig functions. That's the big deal. Not too hard, is it? And just in case you didn't catch it, tan theta is actually equal to sine of theta over cos of theta. Right? Because if we take sine theta and divide by cos theta, the c's cancel and we get b over a. So to help remember how these trig functions work, we use this funny little term, SohCah Toa. Sine is the opposite side over the hypotenuse, cosine is the adjacent side over the hypotenuse, and tan is the opposite side over the adjacent. SohCah Toa. So now let's discover one of the most important relationships involving the trig functions. Remember the Pythagorean theorem? Let me redraw that right triangle so that you'll see what's happening here. Okay, so now let's remember what sine is. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. So if we look at this relationship, sine squared of theta plus cos squared of theta, we see that it's equal to the following. Right? All I'm doing there is squaring both sides. But now I can write this all over c squared as a squared plus b squared. Do you see what's happening here? Remember the Pythagorean theorem? A squared plus b squared equals c squared. And up here we have a squared plus b squared. So this is equal to c squared over c squared, which is equal to 1. And that, my friends, is a big deal. And it turns out that it's always true. Sine squared plus cos squared will always equal 1, regardless of what theta is equal to. Very big deal. This is known as an identity. It's true for all values of theta. And one of the ways that we can kind of show that it's an identity is instead of using 2 lines, we use 3 lines. And what that means is that statement is true for every single value of theta. We can actually get another identity from this very quickly. All we're going to do is divide everything by cos squared. just like this. And now what do you notice? Sine squared theta over cos squared theta is the same as tan squared of theta. This is 1. And 1 over cos is sec, so this is sec squared of theta. And that's an identity also, and so we indicate it by using another line there. So those are two quick identities, two important relationships in trig that we will continually use. You should remember from geometry some very special right triangles and the relationship that the sides have. So I will simply label these and hopefully it will jog your memory. So what you have here is a 30, 60, 90 triangle, and over here a 45, 45, 90 triangle. And these sides are in a very special relationship, and I'll label them for you. So hopefully this looks familiar, and this is the relationship of the sides in a 30, 60, 90 triangle and in a 45, 45, 90 triangle. What we'll do is we'll simply use these and learn what the cosine, sine, and tan are for these very special angles. Alright, so I've filled in all this information. Remember SohCah Toa. So cosine of 30 is adjacent over hypotenuse, which simplifies to square root of 3 over 2. Sine of 30 is opposite over hypotenuse, which simplifies to a half. Tan of 30 is sine over cosine, which will simplify to square root of 3 over 3. And then sine and cosine and tan of 60 degrees is exactly the same thing, just different relationships. But notice that the sine of 60 is the same as the cosine of 30, and the cosine of 60 is the same as the sine of 30. For the 45, 45, 90, it's a lot easier, and you should be able to follow that pretty simply. So those are the really important angles, 30, 45, 60, and what we know now are the sine, cosine, and tan for each of those. For the other three trig functions, secant, cosecant, and cotan, they're simply the inverse or the reciprocal of these functions. So we won't need to write those down each time.